Okay, so we're going to go ahead and pick back up with our exam review here. And let's see if I can make that just a little brighter for us. Let's go. All right, so we'll do a quick little backtrack here. So what I had done before, maybe not very eloquently, but tried to anyway, was draw our precedence diagram. So I think I'm in good shape, Jack. Okay, so our precedence diagram is, again, we say that A doesn't have anything that follows it, B follows A, right? C follows B, D follows A, E follows B and D, so I need 2 arrows there, right? And F follows E and C, okay? And then what we had done is we said A takes 3 days, B takes 4, C takes 2, D takes 5 days, E takes 6 days, and A takes 8 days, right? And so what I need to do to find the critical path is identify the 3 paths, A, B, C, F, right? A, B, E, F, and A, D, E, F, right? And so those are my 3 paths, right? A, B, C, F, 3 plus 4 is 7, plus 2 is 9, plus 8 is 17. A, B, E, F, 3 plus 4 is 7, and 6 is 13, and 8 is 21. And A, D, E, F, 3 and 5 is 8, 8 and 6 is 14, and 8 is 22. So we would say then that A, D, E, F is our critical path.
No.
Oh, I see. I hip checked it. Sorry about that. So when I hip check it, you have to tell me. Okay, so does that make sense? I think we'd added wrong before, right? We had that top one at something different, but it is 17, 21, and 22, okay? And then to keep moving then, so we've drawn our precedence diagram, we've identified the critical path, we need to do earliest start time and earliest finish time. So we're going to draw our T diagrams for each task. Okay, so for A, it starts at 0, ends at 3. Therefore, B starts at 3, ends at 7, right? C starts at 7, ends at 9. I can't do F because I have 2 arrows coming into it till I have both arrows figured out. So D starts at 3, ends at 8. E starts at 8, ends at 14. So the 2 arrows coming into F are 9, right? Ending on day 9 from task C and ending on day 14 from task E. So what am I going to start with for task F? 14, Rachel says, and she's correct, right? And 14 plus 8 is 22. Okay, then I do my backward scheduling. That was our forward scheduling. Our backward scheduling is 22 minus 8 is 14. 14 minus 2 is 12, right? I can't do B yet because I have 2 arrows coming back into it. Okay, 14 minus 6 is 8. So going backwards, I have an 8 coming into this and a 12 coming into it. Backward scheduling, do I use the highest number or the lowest number?
Lowest.
Okay, because that's the latest that it can be completed by. So 8 minus 4 then is 4, right? And again, I can't do A until I get D done, okay? And D is 8 minus 5 is 3, okay? So I have 3 and 4 coming into A, so A has to be
3.
Right? So basically now that I've done that, I transfer it into my table. So A is 0, 3 for early start, earliest finish. 0, 3 for latest start, latest finish. B is 3, 7 for earliest start, earliest finish. 4, 8, latest start, latest finish. C is 7, 9, earliest start, earliest finish. 12, 14, latest start, latest finish. D is 3, 8 and 3, 8. E is 8, 14 and 8, 14. And F is 14, 22. And so my slack time can either be latest start minus earliest start, or latest finish minus earliest finish. So 3 minus 3 is 0, 8 minus 7 is 1, 14 minus 9 is 5, 8 minus 8 is 0, 14 minus 14 is 0. 22 minus 22 is 0. So I have now drawn the precedence diagram. I identified the critical path. So what I'm going to do is just make it very clear. My critical path is A, D, E, F. Okay. I've done my earliest start and earliest finish, and I've identified my slack time. Okay. So we're good to go on that one.
You go back to that. Let's see that.
I'm also going to post these, I'll put a PDF of this solution on Canvas, so if you need to go back to it, we can. And unfortunately, because we were crunched on time, because we couldn't get the Elmo to work, I probably need to keep kind of moving along here.
Okay.
Okay? All right. That being said, then the second problem is again from that alternate chapter 5, right? And it says the following represents a project that should be scheduled using CPM with 3 activity times, okay? And so we know that when we're doing the 3 activity times, when we're trying to do the estimated time, okay, what we do is our estimated time is calculated by taking A plus 4M plus B and dividing it by 6, right? And our variance, when we calculate our variance, we want to calculate B minus A and divide that by 6, okay? So the first question is, well, what's the critical path? Okay, so that tells me that I have to draw it. So there are no predecessors for A or B, right? C follows A, and D follows A. E follows B, F follows C and D, G follows D and E, and H follows F and G. Okay? If I'm going to look at the possible paths here to identify the critical path, I would say we've got A, C, F, and H, A, D, F, and H, A, D, G, and H, and B, E, G, and H. Okay? And rather than actually draw the times on here and transfer them down, I'm just going to, what we have to do is we have to calculate those possible times first, and then we sum them up here to see which one is actually the critical path. So for our estimated time for the activities, right, so I've got activity A, it's going to be 1 plus 4 times 4 plus 7, all divided by 6. I'm going to have you trust me on my math on this. So that's 24 divided by 6 is equal to 4. For B, it's 1 plus 4 times 3 plus 5 divided by 6 equals 3. For task C, it's 2, right? And I'm getting that from our table up here. 2 plus 4 times 5 plus 11. 2 plus 4 times 5 plus 11 divided by 6, right, is going to equal 5.5. For task D, it's going to be 1 plus 4 times 8 plus 9 divided by 6. It's going to be 7. For task E, it's going to be 1 plus 4 times 2 plus 3 divided by 6. It's going to be 2. For task F, it's going to be 1 plus 4 times 6 plus 11 divided by 6. It's going to be 6. For task G, 1 plus 4 times 2 plus 3 divided by 6 is 2. And for task H, 2 plus 4 times 3 plus 3 divided by 6 is going to be equal to 2.8. Okay? All right. So to figure out what my critical path is, I have A, C, F, and H. So A is 4, C is 5.5, F is 6, and H is 2.8. So a lot of times, one of the things I can do, I don't actually have to add all that up if I can do this comparison, right? So then if I do AD, F, and H, I've got 4 plus 7 plus F is 6 plus H, which is 2.8. Well, I can clearly see the only thing that's different here is A and D. And 5.5 is less than 7, so I know that this is not my critical path. Okay? A, D, G, and H, I have 4 plus 7 plus G is 2 plus H is 2.8. Again, the only thing that's different here is the F and the G, and G at 2 is less than my time for F, which is 6. Okay? B, E, G, and H, so I've got 3 plus E is 2 plus G is 2 plus H is 2.8, and again, that's going to be less, so this is my critical path. 4 plus 7 plus 6 plus 2.8 is equal to 19.8. Did you track how I just did that comparison and didn't have to add every single one of them up? Okay? All right, so I've identified the critical path. So if my critical path is 19.8, what's the expected project completion time?
19.8.
19.8. Okay? And again, to make it very clear, I need to write ADFH. I will not give you credit for the critical path if you write them out here and put the times beside them, because sometimes people do that and they don't recognize that the longest is the critical path. So you have to be specific and tell me this one is the critical path. Okay? So then it says, what are the variances associated with each task? Well, the variances then are B minus A divided by 6, and then we square that, right? So B minus A here is 7 minus 1 divided by 6 squared is 1. B minus A here is 5 minus 1 divided by 6 squared is equal to 0.44. For task C, it's 11 minus 2 divided by 6 squared is 2.25. For task D, it's 9 minus 1 divided by 6 squared is 1.78. For task E, it's 3 minus 1 divided by 6 squared is 0.11. For task F, it's 11 minus 1 divided by 6 squared is 2.78. And for task G, 3 minus 1 divided by 6 squared, 0.11. And for task H, 3 minus 2 divided by 6 squared is 0.03. Okay?
You pull that up so see.
All right, so now I've identified the variances for each task. So I can check mark that one. And then it says, what is the z-score that you would use to identify the probability of completing this project? Okay? Well, our z-score formula says that we're going to take our desired time minus our expected time and divide it by the square root of the sum of the squared variances. Okay? And so in this case, what's our desired time? Andrew, what's our desired time? What is the z-score you would use to identify the probability of completing the project within 22 days?
The desired time is it 4?
No, why would you say 4? I'm just curious.
Hold on. What are you asking?
So we're trying to fill in this formula for the z-score, which says take the desired time for the project completion minus the expected time for project completion. So the desired time is coming from the problem. They're saying, well, we'd like to see you completed in 22 days. Okay? So that's our D is 22. So then if our D is 22, what did we say we think we can complete it in based on our critical path?
19.8.
Right. So I'm going to take 22 minus 19.8. Right? And I'm going to divide that by the square root of the sum of the squared variances from the critical path. Don't forget that part, right? So my critical path was A, so I'm going to circle that, D, right, F, and H. So it's going to be the square root of 1 plus 1.78 plus 2.78 plus 0.03, right? So my z-score ends up being 2.2 divided by the square root of 5.59, right? And when we finish that out, it's 0.932 is my z-score, okay? I'm not going to provide a table. I'm not going to make you look up the z-score and tell me the probability. I'm just going to ask you to calculate the z-score, knowing that we can figure out the z-score when we have the appropriate tools.
Is that 2.2 and not 22?
Yeah, because it's 22 minus 19.8.
Yeah, that was just, I mean, it was just confusing seeing it from back here. It looked like 22 again. I was like,
Okay, nope, it's 2.2.
that's what was the answer? 0.937?
0.932.
Okay.
Okay, so that's a second project one. A third project one, right, because we love those project problems, right, is an earned value management one, okay? And the earned value management says a project to build a new bridge. I'm not going to make it big enough. You all have a copy and they'll have a digital copy online. Project to build a new bridge seems to be going very well since the project is well ahead of the schedule and costs seem to be running very low. Major milestone has been reached where the first two activities have been totally completed and the third activity is 65% complete. The planners were only expecting to be 52% through the third activity at this time. The first activity involves prepping the site for the bridge. It was expected that this would cost $1.416 million. It was done for only $1,296,000. The second activity was pouring concrete for the bridge. It was expected to cost $10,496,000, but was actually done for $8,996,000. The third and final activity is the actual construction of the bridge superstructure. It was expected to cost $8,496,000. To date, they have spent $4,996,000 on the superstructure. So the first thing I need to do is organize my information. And so I've got 3 activities. So I'm going to go activity 1, activity 2, activity 3. And I'm going to do a percent complete. And what we know is activity 1 is 100%, activity 2 is 100%, and activity 3 is 65%. Okay? And then percent budgeted to be complete was 100%, 100%, and 52%. Okay? The planned cost of each activity, $1,416,000 for activity 1, $10,496,000 for activity 2, and $8,496,000 for activity 3. My actual costs to date are $1,296,000 for activity 1, $8,996,000 for activity 2, and $4,996,000 for activity 3. Okay? And so it asks us to calculate the schedule variance, the schedule performance index, and the cost performance index for the project to date. So that says I'm going to need to know, what do I have to know to do my schedule variance? This would probably be one of the formulas you want to make sure. I need to know my budgeted cost of work performed minus my budgeted cost of work scheduled. Okay? So if I'm going to do my budgeted cost of work performed, right, we have done 100% of the budgeted cost of $1,416,000. Okay. We have done 100% of $10,496,000. And we have done the budgeted cost of the work performed, and so we've done 65% is what we've actually completed of the planned cost of $8,496,000. So to finish that out, I do the math, so that's 100% of $1,416,000 is $1,416,000. 100% of $10,496,000 and 65% of $8,496,000 is $5,522,000. And I sum those three up to get my total budgeted cost of work performed at $17,434,000. Okay? So that's, I can put that in at $17,434,000, and I have to then calculate my budgeted cost of work scheduled, okay, which is 100%, 100%, and 52%. So again, I'm just going to go 1,416,000, 10,496,000, and 52% of 8,496,000 is 4,417,920. When I add those up, 16,329,920. So to get my schedule variance, it's 17,434,000 minus 16,329,920, and that leaves me a schedule variance then of 1,104,480. Okay. So that answers what's my schedule variance. Another question is then what's my schedule performance index? And I would need to know that my scheduled performance index is my budgeted cost of work performed divided by my budgeted cost of work scheduled. So in this case, my budgeted cost of work performed is $17,434,000 divided by my budgeted cost of work scheduled, $16,329,920 is 1.068. Okay. Does that mean I'm ahead of schedule or behind? Is that favorable or unfavorable?
Favorable.
Rachel says favorable. She's right. Anything over 1 is favorable. Okay. And if I need my cost performance index, it's going to be the budgeted cost of work performed divided by my actual costs. Right? My budgeted cost of work performed, $17,434,000 divided by my actual costs, and I would need to sum up my actual costs up here of $1,296,000, $8,996,000, and $4,996,000. That's going to be $15,228,000. And I transfer that down here and divide by $15,228,000, giving me a scheduled performance index of 1.14. Okay, and again, it's greater than 1, so it's favorable. Okay.
Is that OPI is what you have for that?
CPI.
CPI.
Mm-hmm.
The one above it's SPI, SVI?
Yeah, SPI, Scheduled Performance Index, CPI, Cost Performance Index.
Okay.
Okay, and again, I think those are, I'd gather up those formulas associated with that section and put them on your formula sheet. Okay? All right. Project crashing, right? So it says, what's the critical path? All right, well, the diagram's already been drawn for us, so what I can do is go ACEG is one path, and ACFG is one path. And so it's 6 plus 14 plus 5 plus 2 as compared to 6 plus 7 plus 6 plus 2 as compared to 6 plus 7 plus 5 plus 2. And my pen is dying on me. Rachel, do you have a pen I can borrow? You know what? Yeah, I probably do. Thanks. So this last one is 6 plus 7 plus 5 plus 2. So 25 is 27, right, for A, B, D, G. 6 plus 7 is 13, plus 6 is 18, plus 2 is 20. Is that right? 13 and 6 is 19, plus 2 is 21. 6 and 7 is 13, plus 5 is 18, plus 2 is 20. So which one's my critical path? Yep. A, B, D, G, because it's the longest. Okay? So what's the earliest completion time we could do given the way the project currently stands? Taylor? What's our earliest completion time without doing any crashing?
27.
27. Right? All right. So then it says, for the data shown below, reduce the project completion time by 3 weeks. Assume a linear cost per week. Okay? And so here's what we're going to do. I typically like to just kind of draw this out a little bit to the left. And so to be able to finish this, so that I can keep my tasks straight. So in order to determine which activities we want to crash, we have to get to the crash cost per week, right? We're in weeks. We know what our normal cost is, right? If I run through this right now to complete it in 27 weeks, it's going to cost, if I add these up, they're going to add up to $47,600, right? If I crashed everything for all of these weeks, right, these are the total costs for that. This is not a cost per week. This is the cost if I were going to be able to crash this, right? So my normal time is 6 weeks. My crash time is 2 weeks. That means that I have 4 weeks available to crash for that particular task. So it's normal time minus crash time. So 6 minus 2 is 4. 14 minus 8 is 6. 7 minus 5 is 2. 5 minus 4 is 1. 6 minus 5 is 1. 5 minus 3 is 2. 2 minus 1 is 1. So I go 4, 6, 2, 1, 1, 2, 1. Okay? And then I need to separate out what's the cost of crashing. Okay? Because this cost, right, is the total cost if I were going to crash to that level. I just need to know what the cost of separating out that crashing cost. So I take the crash cost minus the normal cost. Okay? And so it's $12,200 minus $7,500. That's $4,700. It is $18,700 minus $12,700. That's $6,000. Okay? It is $8,500 minus $5,300. That's $3,200. Okay? It's $6,400 minus $4,600. That's $1,800. It's $4,600 minus $3,700. That's $1,200. $8,900 minus $6,500. That's $2,400. Okay? And $7,900 minus $7,300. That's $600. Okay? And so then to get my crash cost per week, I need to divide the crashing cost only divided by the number of weeks that I can crash it.
46 minus 37 should be 9.
What's that second column? She's got some freaking.
Which one?
E should be 900.
4,600 minus 3,700.
Wait,
4,600 minus
And what you do
3,700.
what
Right.
on that column? On the crashing
That
one, you do
off line.
what?
Okay. All right. So I'm going to take 4,700 divided by 4, and that's going to tell me to crash activity A, it costs me $1,175 a week. To crash B, it's $6,000 total divided by 6 weeks. That's $1,000 per week. C, 3,200 divided by 2 weeks. That's $1,600 per week. D, 1,800 divided by 1 is $1,800. Okay. E, 900 divided by 1 is 900. F, 2,400 divided by 2 is 1,200 per week. G, 600 divided by 1 is 600. Okay? All right. So what tasks would you crash at what cost?
You definitely would do G, wouldn't you?
Okay?
Yes.
How do you make a decision?
It's the lowest cost on a critical path.
That's the key. It's the lowest cost. Did you have a question?
No, I was going to say something else though.
Okay. It is the lowest cost on the critical path. Okay. So what I do then is I like to come back and I just asterisk my critical path. So we said A, B, D, G. So A, B, D, and G, right? And so if those are the tasks on my critical path, I have to check to make sure my critical path doesn't change once I change that, right? You can assume for the exam it's not going to. I'm not going to get that tricky on you on the exam. Okay? So that being said, I would task G first because it costs $600. And what would I do next? So I'm trying to reduce the project by 3 weeks. So G is going to take me 1 week, right?
Then you would move to
B.
yeah. B.
B at 1,000, and then B at 1,000 again. Okay. Here's a quick gut check. The only way that would change the critical path is if this critical path were within 3 weeks of the other two anyway, right? And it's not, so it's not going to change the critical path, right? And again, on the exam, I'm not going to be that tricky, right? Right? So then what's the total cost of the project then? How do I figure the total cost of the project?
Add the crash cost to the original.
Right, so it's 47,600 plus 600 plus 1,000 plus 1,000, right, gets me to, I think, 50,200. All right. Show me your work and I'll give you partial credit. Give me only an answer and I'll give you a 0 or full credit. Okay? So make sure that you show your work.
So, and you said if you get it right, though, you get full credit?
Yeah. So if you only write 50,200, right, at the end, I'll give you full credit for it. But if you write this and you're off, your math is off, I'll deduct 1 or 2 points for math issue.
Okay.
Right?
Let's carry forward credit.
What's that?
Let's carry forward credit.
So if you figure it wrong up above, but you do the rest of it right based on what you did wrong to begin with, then I still try to give you credit. But if you don't show me that, I can't give you any credit. Okay?
Sweet.
All right. Any questions?
What's the answers for all the questions?
What's the answers for all the questions?
I need those tomorrow.
I will share those with you after the exam. Be glad to share them with you after the exam. No attendance thing today. No attendance thing today. All right, listen, I hope you all have a good weekend. Study hard. And again, don't be afraid to ask questions if you've got them.
All right, Scotty. Good luck.